Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will go through the core concepts of applied petrology, where the architecture and lithospheric data which will be studied in the view of civil engineering. Here, the applied petrology, which is a common engineering rocks, which includes granite, basalt, sandstone, limestone, marble, and many more. So, granite provides excellent bearing capacity and durability. So, granite is an intrusive igneous rock which form within plutonic batholiths due to its massive structure, which have the high compressive strength. Granite is highly suitable for dam foundations, bridges, and heavy engineering or civil engineering infrastructural projects, where the basalt, which will be the dense, strong, and widely used as crush aggregate. So, basalt is an exclusive igneous rock which form from lava flows, which is a dense, durable, and commonly used as a crush aggregate in concrete, road pavements, construction activity, and railway ballast construction. Third one will be the sandstone. The strength of the sandstone depends on the mineral composition and cementing material, where the sandstone is a sedimentary type of rock which is formed in sedimentary basins. Its engineering performance depends on the type of cementing material. With silica cemented sandstone, generally that sandstone is stronger than the calcite cemented sandstones. Fourth one will be the limestone. Limestone is important for cement production but may develop solution cavities. So that marble, which is a contact and regional metamorphic type of rock, where that will be utilized for the aesthetical purpose with reference to the flooring or any type of tiling work. So engineering applications for that rocks or petrology with reference to its usage, which depends on the rock strength, durability, and weathering resistances. Here the field identification, which is a descriptive part on the basis of tabulated format, where the types of rocks, basically igneous rocks, sedimentary rocks, and metamorphic rocks are listed with reference to some legends, that is of the basis of primary structure, fossil presence, acid reactivity, and hardness, or we can say that a competency. So igneous rocks typically show interlocking crystalline textures. They are recognized by interlocking crystals and massive structure. These rocks rarely contain fossils and generally exhibit high strength and durability. Second one will be the sedimentary type of rocks. They are commonly exhibit bedding and fossil structures. These sedimentary rocks are characterized by bedding or stratification, where fossils are frequently present and engineering properties vary depending on the degree of cementation and weathering action. Third one will be the metamorphic type of rocks. They display foliation or wavy banding. Recrystallization under heat and pressure often produces rocks with high competency and distinctive structural patterns. That metamorphic rocks display foliation and mineral alignments. Here, fourth one will be the carbonate type of rocks that react with the dilute acids also for that identification purpose. Means that field identification which helps engineers rapidly to evaluate geological conditions which are beneath to that earth surface or nearby to the rock masses. So diagnostic criteria provide a rapid field elimination framework before microscopic analysis. Here the mechanical properties which are based on the criteria, that is stress, strain, and rupture. The graphical representation of displacement, diffraction, or we can say that the strain on the x-axis with reference to the load applied or stress applied on the y-axis, where the stress refers to the force applied per unit area. Strain represents deformation resulting from applied stress. So rocks exhibit elastic behavior until the elastic limit is reached in the initial phase. Brittle failure occurs suddenly with little deformation. So mechanical properties determine excavation, foundation, and slope performances, where the stress and strain describe the mechanical response of rocks under loading or on the weight. So relationship between applied force and deformation determines the behavior of rock masses in engineering structures. So the elastic limit, which represents the maximum recoverable deformation. Beyond this limit, that rocks experience permanent deformation and may eventually break or brittle failure. So the rocks may exhibit brittle failure or ductile behavior, which depends on the conditions. That strong rocks like sandstones often fall down suddenly, whereas shale and marble type may deform plastically under some confinement, which is explained as the graphical representation. Next one will be the environmental degradation, where the weathering of rocks will be seen. The mechanical breakdown, first image, and second one will be the chemical dissolution, where the chemical attack will be seen. The mechanical weathering, which causes physical breakdown of rock masses, where pressure release leads to exfoliation and sheet fractures, particularly in massive rocks just like the granite. Chemical weathering alters minerals through dissolution process, where limestone, gypsum and salt deposits are especially vulnerable to chemical degradation. So here, subsurface dissolution may create voids and collapse structures. So this process can result in sinkholes and ground instability that pose risk to engineering projects. So means that chemical weathering alters mineral composition through dissolution and reactions or chemical reactions, whereas mechanical weathering physically breaks rocks into smaller fragments. Means the pressure release may cause explosion and sheet fractures, where the limestone and evaporates are vulnerable to solution weathering. Means that weathering reduces rock strength and affects the engineering stability at the same time. The architecture and the lithosphere point of view, we see the solid outer shell of the earth, that is the lithosphere, or we can say that the surface of the earth, which is dominated by crystalline solids dictated by rigid mechanical properties. So the lithosphere is primarily composed of crystalline rock materials. These rock consist of aggregates of minerals like quartz, feldspar and mica. These minerals possesses definite chemical compositions and crystal structures, where the physical and chemical properties control the engineering behavior of rocks. The atomic lattice arrangements determine mineral strength and rigidity. These microscopic characteristics influence the mechanical properties of the lithosphere or the surface. Means the rocks are the aggregate of one or more minerals. Mineral possesses a definite chemical composition and crystalline structures, so that the engineering characteristics of rocks which are depends on their mineral composition only. So the knowledge of that mineral as a civil engineer point of view, which is most important to check the assessment, durability point of view, weathering resistance and strength characteristics. Next one will be the lithic blueprint, that is a master classification of rocks. On the basis of that lithosphere, the whole rocks are of the three type: igneous, sedimentary and metamorphic. So the lithosphere is broadly classified with reference to three type of rocks. Each category is formed through a distinct geological process and possesses unique engineering characteristics. That igneous rocks, which are formed by magma consolidation, sedimentary rocks are by lithification, whereas metamorphic rocks are by recrystallization. Their origin strongly influences durability, permeability and structural behavior. Means the engineering point of view, the each type of rock is suitable, which depends on the rock competency and weathering resistances. Here the granite and basalt generally provide high bearing capacity, whereas soluble rocks such as limestone may present geotechnical hazards. Here we see that the rocks are classified with reference to its pattern, just like igneous, intrusive, exclusive, sedimentary, clastic, biochemical, chemical, metamorphic, foliated and non-foliated, and the examples are listed below with reference to its texture. Means the sedimentary rocks form through deposition and lithification of sediments, whereas metamorphic rocks form through the heat and pressure action, or we can say that the recrystallization methodology. Means basically, with reference to the engineering point of view, we have to check the suitability of rock for the selection, site selection criteria for any structure, or the foundation characteristics, which depends on their rock origin, texture of that rock materials, minerals which are present within the earth surface, geological explorations, and all other weathering characteristics due to some external or internal factors, just like tectonic forces, groundwater, or any fossils which are available within the rock layers. Stay tuned, guys. Happy learning.